So good afternoon, my student, and today I take this chance to welcome you to our chemistry lesson. Feel welcome. We are going to discuss classification of substances. We call it a simple classification of substances. So I welcome you. Allow me to take this chance to welcome others in form of sending them the link. Otherwise, have a blessed day as you enjoy the lesson. Yes, just a minute. I'm almost there. Great, already there are people who are with us. Welcome, shifting grades, invite people. Shifting grades, take that link and invite as more people as possible. Yeah, we are starting right now. In the next minute, I just want to invite some of you. That's how I do it. Now we can proceed. So I'm divided into groups. There's a group here in the laptop which I'm following them. I'm teaching them, but now we have you who is following everything. If I read something on the board, you proceed. Now, so this time, allow me to introduce to you our topic, classification. So that there are some questions I ask my members here, but we can answer those questions while you are also following. So let's go to these questions. It's a particular question. Is chemistry important to the society? You are supposed to respond with a yes. Still explain. Then what's a drug? You ask what's a drug? What's prescription? What's a dose? Then you are told to give 4 drugs that are commonly abused. Then give any 5 harmful effects of drug abuse. Then swali ingine ni why is it important to follow the doctor's prescription when taking medication? Give the names of the apparatus used for measuring the following. Now to answer question 1. You are 10 there, and I can see, and we have like 10 questions. So who can start with us what's chemistry? That question has been answered very many times, but we can still go ahead. We should not tire of doing that. Let's do it very fast. We can go back. We can go to our topic for today. The questions we've just mentioned, let it be an assignment because the people are supposed to ask the questions are not ready. Now, let me change. I present now what we are supposed to discuss today. Hebu mtafutie kwa hizo sasa nisoka kwa shelf. Mtafutie jana kwa jina. Haya sawa. To check with them right now. If you talk about solid mixtures, it is the mixtures in which the substances making up that particular mixture, all of them are solids. We call it solid mixtures. And some methods that we use to separate solid mixtures include magnetism, winnowing, hand picking, sublimation. In fact, others requires that we use, we dissolve the mixture in water. There are very many. Now, when we talk about solid liquid, it includes sand and water, salt and water. There are very many. As long as one solid, that one is a liquid, it qualifies to be called solid liquid mixture. Then we have a table. So, when we talk about solid liquid mixture, so we have liquid kama water and paraffin. All these we are going to see how they are supposed to be separated. I hope you're following, everyone. I hope everyone is following. Yes. We proceed. So I want to give the objectives of the lesson. Yeah, by the end of this lesson, what are you supposed to be able to? By the end of the lesson, you should be able to define some terms like element, mixture, atom, molecule, compound, some terms like melting point, boiling point, and sublimation. Also, by the end of this topic, or this chapter, you should be able to write chemical symbols of common elements and identify some of the constituents of compounds. If we give you a compound like sodium oxide, what composes this particular compound? So that you will tell me it is sodium and oxygen. It's what we need to know by the end of this topic. Also, you should be in a position to determine the percentage. Not the percentage, simply the purity of substances, and use separation techniques to obtain those pure substances. So there are very many ways in which you can know whether, for example, if this is water, whether it is pure or not, whatever substance, whether it is pure or not, we will check up on that. Then by the end of the chapter, you should be able to differentiate between permanent and temporary changes, giving examples and characteristics. So now I want us to start by looking at what a mixture is. First of all, what's classification? Classification is used mainly in biology. It is the process of grouping together substances with similar properties. Sand and iron filings. If you put together iron filings, then you put together sand, you will say you are doing what you call classification, because you are classifying based on similarities. Now, let's start by looking at the term mixture. What's a mixture? For those who are following me here, I think I've displayed for you. Mixture is a material made up of two or more different substances. It should be different substances which are physically combined. By physical means, like if you mix maize and beans, that's one of the most common mixes I always use. So it will be said to be a mixture because maize are different from beans. That's a mixture made up of two substances. Actually, they can be made of more. Na ingine iko na more than 2, iko na 4, ingine iko na 5, and all of them we will learn how they should be. Yes. Then we have insoluble. If this liquid, we will split into two. It depends with the physical properties of what you are supposed to separate. Somebody is asking, can you say that a mixture is two or more substances mixed together in which the individual components forming the mixture retain their physical and chemical properties? Good. It can still be said that way. Yes. That is true. What you are saying? Yes. Let's proceed. Now, like upon the method number one, use of a magnet. Use of a magnet. Use of a magnet. So the method number one that I want us to discuss is use of a magnet. Use of a magnet. At what point do we use a magnet? If one of the mixtures is magnetic. And in most cases, to rule out any discussion is one of the commonly used magnetic material is iron. Look at this, a mixture of iron and sulfur. A mixture of iron and sulfur. A mixture. I'm not saying a combo. A mixture of iron and sulfur. If you want to separate them, we will use a magnet. Why? Because iron is magnetic. Yeah. Because iron is magnetic. And when you have a mixture of iron and sulfur, remember, sulfur is yellow in color. Iron is gray in color. When you mix the two, it forms a mixture whereby if you look at it very keenly, you will realize that you can still see some gray particles and you can still see some yellow particles of sulfur. That's a mixture. So if you want to separate them, in most cases, people will say, students will say, you pass a magnet of it. Look at, I hope, let me think this. Can you see this? Can you see what I'm writing on the board? Somebody? Can you see what I'm writing on the board here? Okay, so now, look at, if you have a container like this, now we're gonna mixture iron and sulfur, then you pass a magnet, it will only pick the ones on top. Lakini, it will not pick the aliphanes and it will go down. But if you spread the mixture on a flat surface, you take this mixture, then you spread on a flat surface, it will pick all the aliphanes. That is it. Yeah, let us have it. Even now. So that was our first method. It's called magnetism. So let's proceed. Let's look at an used when one of the methods undergoes or it is magnetic. But so now method number 2 is sublimation. Sublimation. So sublimation is used when one of the components of mixture will undergo sublimation. Examples of a substance which undergoes sublimation. Sublimation is the one that which undergoes directly from solid to gas. An example of it is iodine. Iodine is one of the most example. It changes directly from solid to gas. One of them we may say iodine. Yes, iodine is one of them. Because it matters that.
Anything checks the ink.
Fanya hivi sote hii maandishi kuja hapa chini. Sawa sawa. Maandishi kuja hapa chini. If you want to describe sublimation, you want such a diagram whereby hapa ikuwe ina undergo heat 3 constant na hapa ikuwe na wire gauge. Wire gauge is meant for uniform heat distribution. Then hapa ndio tuko na mixture yetu. Here is where we have the mixture of maybe sodium chloride and iodine. Then up ultimately you have ice cold water or simply cold water. So when you heat at this particular point, iodine which undergoes sublimation will supply and get deposited. So general name substance X, this should be iodine. So before you answer this question, first of all, you must be aware what are some of the examples of substances that undergoes sublimation. Because if you don't know that, then you cannot answer it. Umekubali?
Bado tu inakata.
Hapo tutafanyaje?
Ni ink imeniambia sijui check.
Si ink inaongea niko lakini I don't know.
Ama jaribu tuongee kwa ingine. Hii yenye imekataa hii.
Hebu jaribu tena uone. Ya mwisho. So examples of, apart from iodine, other examples of substances which undergo sublimation includes, for those who are writing them down, you can note them down very fast: anhydrous iron 3 chloride, aluminum chloride, benzoic acid, and dry ice. What's the term for dry ice? Solid carbon 4 oxide is what we call dry ice. So when you heat, the water that undergoes sublimation changes directly to gas, and then it gets deposited at the cold parts of the container. Yes. So what are some of the applications of sublimation? Who can answer this question? Applications of sublimation? Who can do it for us? Kayla, can you try? What are some of the applications? Kayla is not in our class. Ukipata nje ya class usicomplain. Juliet? Janice?
Can be used for painting, applications of cleaning, in applications like that.
Reagan? Now, can you write this one as applications of sublimation? Dry ice in cold boxes by ice cream vendors. Yes, used by ice cream vendors. Why is dry ice preferred? Because it sublimes, leaving no wetness. It is also a better coolant compared to ordinary ice, so you can put them down. While first of all, we are talking about application of sublimation, and we have picked one that dry ice is used in cold boxes by ice cream vendors. That's the application. Now, another question is, why is dry ice preferred? Because it applies little no wetness. Nani ako na swali ako? Eunice? What is the purpose of the cold water? To cool the sublimed substance back to solid. Are you together?
Yes.
Yeah. Haidi anasema dry ice is used to in cold box for ice cream. That is correct. Yes. Now let's look at something else. Let us look at now solid liquid mixture. solid liquid mixture. Kama tu venye nilikuwa nimeandika hapo, we have two categories of them. The first category is the ones in which the solid dissolves and in which the solid do not dissolve. Look here. When we talk about solid mixture, solid liquid, I will split mara mbili: soluble, solid, and insoluble. Kumbuka, someone is raising their hand. I'm scared. Okay. Of a solid and liquid. The solid is called solute, while the liquid is called solvent. Now, if the solute, okay, if it forms a solid, so sometimes it is soluble like sodium chloride. Soluble like sand. If it is soluble, we have to apply a different method of separation. But if it is insoluble, in fact, let's start with the one which are insoluble because it is the easiest. If the solid is insoluble, what can we do? We simply apply some methods like decantation, filtration. Yes, those are the two that we can use. You decant or you filter. Somebody will talk of you sieve. Sieving applies, yes, but sieving will still allow some small particles to pass through. If the solid is soluble, then which method can we use? If it is soluble, again?
Filtration.
Pardon?
Filtration, you can add water then you filter.
If the solid is soluble in a dissolved ndani ya the liquid ama the solvent, how can we separate it? Yes? Exam filtration. Filtration is used when it is insoluble. Niambie? Yes, evaporation. When you put sodium chloride, somebody saying you cannot see the board. When you use sodium chloride in a dissolved dynamite, so you have to apply evaporation. I want to give a question, and everybody has to answer me. Imekupata mimi imekata?
Imekata.
Sawa, mwambie.
Uko na maji mpe? Ya black.
Ndio hii ya.
Alafu na ya ni ya kusave. Ile dawa.
Iko kwa ile room nyingine ukutana kwa msichana kule.
Sawa.
So I'm saying I want to give you a question. Describe the process on how to separate the following. The one following on YouTube, make sure you answer this question. How do we separate the following? A mixture of sand, on how the three can be separated. How can we go about it?
First, we use a magnet to remove the iron filings.
Magnet. Followed by?
Then we add water.
You add water.
Then we filter, separating the sun.
Filter to separate the sun from?
The mixture
From what specifically?
from the water.
Okay, so from the water. Now, anybody with a different opinion, please, before I explain? I will read your answer. But in the meantime, allow me to explain. So you have C, then we have iron filings. So when you have such, the first one to be removed is the one that is magnetic. We have the mixture surface. Spread the mixture on a flat surface, then pass a magnet over it. Hapo utaondoa iron filings. Number 2, add water. Add water to dissolve the salt. Baby, add water to dissolve the salt. Number 3, guys, filter to remove or separate sand from the salt solution. Number 4, malereka na kufika evaporate. Let me when we evaporate now, you separate water from the salt. Kumbuka tuliadd maji na maji was all part of what we are supposed to be separating. So the last step will be evaporation. Tuko pamoja? Yes. Sawa sawa. Yes. So, if you want to separate the insoluble from insoluble solid from a liquid, you filter or you decant. But the decantation is not the most efficient because it will still allow some particles to pass through. So that can find kitu inaitwa filtration. Filtration is good because it does not allow even the smallest particles to pass through it. Filtration, we use a filter paper. Do you know how to fold a filter paper until it is used? Filter paper, ukiangalia kwa lab iko round. It's just a circular object. but we are not supposed to use it this way. Ukisha fold in half, you fold it into a quarter. Fill the paper this way. Then you mix it. So it's called Tonyabia. What do you call the substance that pass through the filter? Michelle Muganda filtrate, which is okay. What do we call the ones that remain? Yeah, I need them as a filtrate. It's okay. So, the one that passed through is called filtrate. Now, you remember them? Boys and girls? Again, Eunice data guide. I have a very simple question. Let me see what we are to oh yeah, what are you to go residue? That is from Heidi. It's known as residue. This is the filtrate, and this is the filtrate, and this is the residue. Nice. Let's proceed. What did I say? Decarnation is not the most efficient. What is the reason as to why decarnation is not the most efficient method of separating mixtures? Let me ask Beverly. Beverly, why? Where is my friend? My friend Michelle Mukai. Yes. I want to get to resume. Michelle Mukai ndio amekataa kuresume. Juliet Masi.
That method is not efficient because some solvents still pass into the water.
What somebody has also said on the side of the YouTube will still pass through. Some substance can pass through. That is from Heidi. Thank you. So to delay, may discussion in this manner. Application. Sorry, my email role. Applications of filtration. Where do we apply? I'm scrolling for you, alafu inaji inajipeleka sijui mpaka wapi. Hii laptop imefanya kazi tangu asubuhi, ndio maana inakataa scroll. Okay, my question is applications of filtration. Where do we apply? Just if you ask about applications of filtration of water purification plants, that water can pass through a filter bed. It will not be necessarily a filter bed, but there's a way that filter bed can be made of rocks, made of wires, made of sand, vitu mingi. So mud water can pass through, but on the other side, it will be very, very clean water. All the particles will have been suspended and trapped by the sand while they are passing through. How do we separate this? Let me give another question. Now, if you are given sand and salt only without iodines, how do we separate them? Your explanation will be very short. If you give to a Form 1, mwambie, how do we separate sand from salt? Atakuexplainia direct. But if you ask a Form 2, especially when you're in Form 3, how do we separate sand from salt? Atakuuliza swali. Atakuuliza, is this salt soluble or insoluble? I'm talking about the soluble salt. You know, if one mostly you've not, they don't even tell that kuna salt zingine yenye soluble, ingine ni insoluble. Yeah, so I'm talking about the soluble salt. So how do we separate sand from salt directly? So the process is very short. Add water to dissolve the salt. Filter to remove or to separate the sand from the salt solution. Then the last step is evaporate the salt solution to obtain the salt crystals. Hapa hapo tuko pamoja. Yes. Yeah. So let's look at what we call crystallization. Before we discuss crystallization, I want somebody, Heidi from the YouTube, you can define for us what is a saturated solution. What is a saturated solution? Hiyo mnangojea Heidi aniambie nini. What is a saturated solution? Alafu watu wa Google Meet, I know already, nimewa expose here what is a saturated solution. A solution that cannot dissolve any more solid at a given temperature. Is called saturated solution. Saya hakuna Now, swali ni if you add water, it will dissolve. You keep on adding, it will dissolve until as you add more salt, it will not dissolve. So now the solution in which no more solid can dissolve is called saturated solution. It happens under a constant temperature. After we add imekataa to dissolve, then we call it saturated solution because it can't dissolve anymore. You know why? Let me take you to this one is always taught in physics. In water, like this, let's say it is water, the particles of water behaves this way. So the spaces in between the water particles and water molecules are the ones that the solid occupies when dissolving in a filled spaces. So when all the spaces are been filled, when all the spaces are filled, then there are no more spaces. So when you add more solid in a particle which become particles, why? There are no spaces to fill. But if you heat, you increase the inner molecular distance and it allows more solid to continue dissolving. That's why when defining saturated solution, it will be at a given temperature. So the process of obtaining the crystals from a saturated solution is called crystallization. It's called crystallization. It is called crystallization, yes. Let's discuss the process of crystallization. Let's discuss the process of crystallization. To obtain the crystals from a saturated solution is called crystallization, and it takes place this way. Okay, first of all, you can form your saturated solution by taking a beaker, you put some water, you add a lot of solid like copper 2 sulfate, crystals, you add them here, you dissolve until it forms more copper 2 sulfates, they don't dissolve. Then you will know that it has formed saturated solution. If you want to obtain back the crystals, it's very simple. Put the wire case on the put water up to a given level, equal water, but we are supposed to heat water so that this water can produce steam. It's the steam that will heat the saturated solution. Saturated solution. We don't heat directly. And it's the reason why during crystallization we don't heat the solution. What is the reason? Our height Kama umenisikia andika yes. That. Areta, what's your reasoning for that? Beverly? Beverly, ada juga metabolism. Reagan? Did you hear the question first? Recruit yes, why?
Why we not hit directly into the water pipe?
Yeah, why we don't hit directly, we use a water bath. We need a gentle heating so that first of all the solution out. If you hit directly, it spat out. Then if you also hit directly, the evaporating dish will break. Now, we don't hit the solution to dryness. We always hit the solution. We use a glass rod. You hit while using a glass rod. You dip the glass rod into the solution, then you expose it to air this way. If you want to form crystals, you stop heating. Now it's enough to form crystals. We don't hit the solution to dryness because of two reasons. One, so that large crystals can form. Number two, so that crystals containing water of crystallization are formed. So that water of crystallization are not removed. Yes. Before to tuendelee nani hapo na swali? Now let's look at the three applications of crystallization. Extraction of salt from salty water, like in Ngomeni, in Malindi, or Lake Magadi. Extraction of sugar from sugarcane. Then extraction of medicinal substances from plants. Yes. So you can put them down. Haili umenipata ama unataka nirudie? We can proceed. Let's look at what we call simple distillation. Simple distillation, remember we have simple distillation and we have fractional distillation. A very simple setup, we call it fractional distillation, especially the ones that do not have a fractionating column, we call it fractional distillation, and it is simply evaporation. Look here, if you don't separate water from salt, then you apply evaporation. You have water in a beaker, and then you have salt, the same beaker, so you have a salt solid. Then if you heat, water will evaporate. You will only remain with crystals. Have you separated? No, you have not separated. You have obtained crystals from a solution. But if you have to separate, separating means at the end of the day, I want to have water, then I want to have the salt. There's a difference between describe how to obtain salt from a salt solution or describe how to separate water from salt in a solution. Separating this from this meaning at the end of the day, I want to have my water and salt. But if I say how to obtain the salt, so where water will go, I don't want to know. Now that one you can apply evaporation, but separating water from salt, then in that case you must use a technique whereby all the two has to be obtained and call it simple distillation, like the one shown here. Look at this. If you have a boiling tube, and this boiling tube is gonna kuna katube kametoka hivyo, huku kuna boiling tube nyingine dipped in cold water. Equate cold water. So if we have salt solution here, then you heat. The vapor itaenda hivi, that is the water vapor. Ikifika huku inakuwa condensed back to, it is going to be water. What will remain here is the crystals of the salt. So this is called simple distillation. Evaporation will go to the atmosphere. Yes. Juliet, are you seeing what I was explaining on the board? Juliet Bassi?
Yes.
Okay. Is it visible? Is it visible?
Not that much.
Or not so much, but you can still see it. Right? Can you see what I explained on the board? Okay, sawa. Now that was a simple distillation. Now, when it comes to fractional, you tutaangalia fractional distillation baadaye. But for now, This one is still the one you can see on the board. Now, I want us to see how we can separate liquid mixtures. And then touch it on the camera. One, two. One, two. Okay. Now let's look at the liquid mixtures. I'm going to categorize them into two ways. When we talk about liquid, so I will split them into two: miscible and the immiscible. Miscible and the immiscible. Can you give me an example of miscible liquid mixture? Mwingine anapatia immiscible liquid mixture. From my guys in YouTube, give us example of miscible and immiscible liquid mixture. Water and milk, that is miscible. Why? Because they form homogeneous layer. Water and paraffin, immiscible. They form heterogeneous layer. So example here, you can say water and milk. Example here, water and oil. They do not mix. Now, if you want to separate this, there are various ways in which you can use to separate, yes. But in our case, right now, we don't study them. In Form 4, later on, we will learn that this one can be separated by use of a centrifuge. But water and oil can be separated by use of the following methods: degradation. You can use a separating funnel. You can also use another process that works well, like a separating funnel, is curate. Curate can work well. Unaifungulia mpaka mahali fulani, then you let it go. Then from there, kuna kalea fulani you always discard. It cannot be part of the top or the bottom because it's a mixture of the two. Now, apart from centrifuge here, There are some others here which they mix, but we can separate them using fractional distillation. For example, if I give water and ethanol, they do mix, but we can separate them. How do we separate water from ethanol? We use fractional distillation. Fractional distillation. Are you together? Gather please. Yes. Sawa sawa. The setup of fractional distillation, I will not draw it for the sake of those who are following me on my YouTube channel, but the ones which we are here, let me just read for you the parts. We have fractionating column, we have the glass beads, we have thermometer, we have water in and water out, and you should know the direction of water in and water out. Then whatever will pass through is called distillate. The one that passes through the filter paper, we call it filtrate. Now, the one that passes through the filtration process, the one that is being collected pale kwa a flask, is we call it distillate. Now, I want us to start one by one. The role of the thermometer, fractionating column, glass beads, Liebig condenser, then why in or during fractional distillation. Nataka mtu mwenye atanijibu swali. I need somebody who will answer me this question. When collecting the distillate, we always use a narrow neck container or flask. In most cases, conical flask. Why don't we use a beaker like this to collect the distillate? Yeah, everybody. Are you seeing what I've drawn on the board? Okay, first of all, have you heard the question? Unaona hii, mbona hapa tunatumia a narrow neck container but not like this one? What could be the reason? Reagan? Sijakusikia walai. That's one of the reasons. In fact, it wasn't there in my mind, but it is correct. Now, there's another reason. Michelle Mungai, I want to hear your reason. Let me hear from Dr. I will not ask Dr. Beverly. Beverly has refused to answer the questions. And when I make a laptop on, na akaenda shughuli. Now, the other reason is why we use this, from this particular container inakuja hivi. Juliet?
Can I try?
Yeah, try.
Collecting of fractions should be done in a conical flat in a beaker to reduce the rate of evaporation.
Thank you. That was the reason what I was looking for. Sometimes the droplets here, some of them are still in the gaseous state. So in fact, ikiingia ndani ikiwa bado iko in gaseous state, they will not evaporate out. There will be enough time. There will be enough time for them to condense back to liquid. Or those which are already in a liquid state, even if the temperatures are high, it is a narrow neck to reduce the rate of evaporation. Hapo tuko pamoja hapo. That is very well. Hapo ninaifurahia. Sawa. Tuendelee na discussion yetu. What is the role? I want the people to do this. What is the role of the heat? 1. What is the role of the glass bit? 2. What is the role of the thermometer? 3. What is the role of fractionating column? 4. And what will happen if the direction of the water is reversed? You've heard my questions. So, ndaka niwape a few seconds kila mtu achukue yake. Juliet, unataka kujibu gani?
The role of glass beads.
Tuambie.
They are used to increase the surface area for condensation.
Thank you. Used to increase the surface area for condensation. Reiken.
The role of heat.
Yeah.
Used to heat the solution so that the evaporating point and the boiling point range.
Thank you. Sawa. It is used to heat the fraction until their boiling point. Now, who will give me the role of fractionating column? Mercy.
It allows the vapor of the liquid with the higher boiling point to condense and flow back to the flask.
Good. For example, if you are separating water from ethanol, then the thermometer is reading 78. So we know very well it is ethanol we are collecting. But now, in the event that some evaporation can take place at any temperature, some water will still evaporate at 78. So fractionated column will ensure that they are being cooled back because their boiling point is not yet reached. Has anyone mentioned the role of the thermometer? Okay, who can give us the role of the thermometer in fractional distillation? Munga?
It is used to know the collected at a particular temperature.
It is used to?
To know the liquid which is being collected at a particular temperature.
Yeah. It is used to show which fraction is being collected right now. For example, if you want to apply crude oil, crude oil has been separated. Okay, scale purification of crude oil, they are simply separating them into diesel, kerosene, petrol, the gas being used as fuel at home. Yes, it's all of them. Now, it is the thermometer that shows which fraction is being collected right now. If you change temperature, then whatever is being collected is different. That is the role. Mercy, I've seen your hand.
I've already answered. I wanted to ask what you said.
Okay. Sawa. What will happen if the direction of the rivers of the water in and water out is changed? Let me hear from Wahome. Okay. Kuna kitu kidogo hujasema haishi ungesema. Hivi masi yasema. Evaporation, okay, condensation will still take place but less efficient. If you change the direction of the water in and water out, condensation will take place but itakuwa less efficient. Did you hear me?
Yes.
Okay. Applications of fractional distillation. Applications of fractional distillation. They are there. I'm giving you 1 minute to record them. A highly separate liquid air. I don't know which question why you answering. Separate liquid air. That is the question I've just answered, Juliet. What would happen if the inlet and outlet were interchanged? That is, what will happen if the direction of the water in and water out is reversed? Condensation will still take place but less efficient. Masivaskin?
Yes.
Applications, there are only 3, but one of them is split. There are only 2, but one of them is split into 3, such that we have 3 points. So applications of fractional distillation, distillation of crude oil to obtain the various fractions kama diesel, petroleum, cooking gas, what else? Ila kuja barabara inaitwaje Wahome? Simulikumbushe. Ila kuja barabara inaitwaje? Hapa taniambia? Aya, mwende mtafute. One of the products from crude oil that is used to tarmac roads ni gari. Niati, sema?
Sawa.
It is called tar. Yes. So that application, even Pictamen, it's the same thing. Pictamen from that is from Michelle. Good. The other one is recycling of used oil at Atriva and Kikuyu Town here in Nairobi. Then we have the manufacture of nitrogen and oxygen by the British Oxygen Company, POZ, still here in Kenya. This is the British company that is doing almost everything. So now tuangalie solvent extraction. It is not the last, but we will still check on something else. So just I want to give you a break here. Kuna mtu anasema kitu? Okay, sawa. I want to give you a break here 2 minutes. I just want to exchange the battery ya camera. Naona inaanza kuniletea warning inasema you change. Sawa. So take a minute, we come and look at solvent extraction. We still have 20 minutes or 15 minutes to go. One, two. One, two. One, two. We can proceed now. Are you still with me? I'm saying that. Okay, so. Remember, tomorrow it will be 6 and we shall be finalizing with the density. I love to answer force. Just follow me pole pole. By the end of the holiday, tutakuwa tumeanza kazi vizuri sana. So wewe usiogope. Tutakuwa tumemaliza na chemistry ndio inasonga mbio because by the end of this week tutakuwa tumebakisha tu mbili kama ya form 1. Next week tutakuwa tuko kazi ya form 2. Kitabu form tutakaa because that is where chemistry is. Then we get form 3. By the time form 2 this month, so that together December, we can see form 3 too. Every Saturday, on Saturday we shall be discussing modes. Watu wa form 2 na form 3 wote, lakini itakuwa on live on channel haitakuwa. So let's look at what we call solvent extraction. Solvent extraction. Solvent extraction. Solvent extraction. It is the process that allows the separation of 2 or more components, especially if one of them is having a different solubility, temperature solubility from the other one. Mostly, it's applied to obtain oils from those seeds or plants containing oil. Unajua, umewaenda kwa supermarket. Sitaki tuanze kupromote supermarket hapa niseme. Anyway, kuna super unapendanga kwenda. I don't know ni gani. Pia inategemea wewe sema napendanga super fulani, kumbe ni venye wenu haiko. So not wa Naivas, not wa Ketias. Hapa Limuru tuko na Clean Shelf, tuko na kani nyingine. I think those are the main 3. Hakuna moja nimekosa kumention ndio wasisema hivyo. Au petangi no, you have Ketias. Kuna mahali unafikana kununua mafuta ya kupika, unapata ziko mingi. Kuna Eleando, kuna Rina. All these they are obtained from plants. Hata upata wamechora mahindi kwa hiyo container. So how do you obtain oil? Kuna zingine zinatoka sunflower. So ziko mingi, ziko aina mingi. But the process is one. It is being crushed. You add a solvent. After adding a solvent, you decant. Then you will have your oil. For example, look at this. Actually, you could one, you crush. That is process number 1. Number 2, you add a solvent. You will give me an example of a solvent. Nikiandika process number 3, be thinking of which solvent is being used. Number 3, evaporation. 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 Which solvent is being used? Let me get from somebody. Nana Maria Sinkono. Aya, Reagan.
Propanol.
We can use propanol. Or another option. You can use ethanol or propanol. Now let me change the question. Why can't we use water? Reagan?
The oil does not dissolve in the water.
So the water does not dissolve the oil. Start with water. Water does not dissolve the oil.
Yes.
So we start by crushing. Okay, if we are doing in the lab, in a demonstration, we will crush using pestle and mortar. We crush using pestle and mortar, then we add solvent. Let me ask another question. Why do we have to crush before adding a solvent? Wahome?
To increase the surface area which the propanol is in contact with the groundnuts.
To increase the surface area upon which the solvent will dissolve the oil. Good. Then evaporation is done so that it can remove the solvent used. We remain with the oil. Applications of solvent extraction. It's applied in obtaining useful substance from plants such as oil. It is applied in obtaining medicinal substances in plants. Applications do you? Extraction of oil from nuts and seeds, natural dyes from plants, caffeine from tea and coffee. Then in dry cleaning to remove dirt. Some of you, amjai peleka nguo dry cleaning, hebu siku moja. Lakini hapana, unajua dry cleaning you can be charged even 200 shillings per cloth. Na nguo umeno 150. Aita adapt. Kuna venye haitashika vizuri. So nini, stick to sabuni na maji. Aya, let's proceed. So nataka tuingie kitu inaitwa separation of colored substances. Chromatography. So that will be our last part for the day. If you want to separate colors, we use the paper chromatogram. If you have never seen a paper chromatogram, it is simply the filter paper you have in the lab. Ile filter paper nilikuwa nimekuchorea sasa hapa. That is an example of a paper chromatogram. And how is it possible that you can separate the two? Let me explain something here. Let me clean the board and I explain something here. If you have a filter paper this way, there are substances which have already been dissolved using a propanol. There are two things that will determine how far they will move away. Solubility. How soluble are they? If the substance or the color of or whatever you are talking about is highly soluble, it will move the farthest distance. How about the number 2? I don't know which name I can use. That particular substance can stick to a material. That material can absorb that particular color of a substance. So absorption ability, absorption. If it has a high absorption power, absorbing power, you just move less because it sticks to the material. Now, mostly we don't use a circular thing like this. We always cut a piece like this so that we work with this one. Now, I can transfer this to the other candle. Always, that is what we always use, but not in a circular way. Whereby this part is the baseline. That's where we place our mixture. Then they will move. The farthest they can move, you will call it solvent flow. So we have the baseline, then we have the solvent flow. Are you following my explanation? Yes. So the upper part is the solvent flow, the lower part is the baseline. Now, the farthest it can go, it just is highly soluble. The lowest it can go in a material is less soluble. So that is, the paper used is called paper chromatography, and the method is chromatography. I want you to get me clear there. Yes. Now, let me say this. Where or what you get ready for that. Usually, in the applications of paper chromatography and chromatography method, but let me say this. There was this question in KCSE. It was asked in KCSE Jana, I don't know when was paper 1 chemistry done. Waliuliza, unajua ukiwa na chromatography hivi, you have to draw the baseline. And the baseline is drawn using a pencil, not an ink pen. We don't use the ink pen, we use a pencil to draw the baseline. Who can explain that? Reagan?
The reason we don't use an ink pen, instead we use a pencil, is because for the ink pen it will interfere with the results, because itself it has colors in it, the color of the ink. But for pencil, the colors would be separated.
Great. Separate. Ink pen is made of mixture of colors. It will separate into. Utapata imefika huku ikienda sijui wapi. So that was the way. That question was there in the exam. Watu wengine wanasema swali hatujaifunzwa. If someone mwenye ako form 1 anajibu swali, then hao watu wengine wasimletee. Haya. Kuna swali moja nataka tufanye wote. Alafu tukuje tuangalie applications. Let me just take you back huko chini. Yeah, I'm looking for one question down here. I know it's here. I'm just getting there in a few minutes, in a few seconds, not minutes. I'm almost there. So there is this question. We were just doing one question. Yes. You can see that question. Let me draw it for the sake of Matema wa YouTube. So we have the baseline there. Then we have substance. We have A1, A2. We have A2 here. Then we have FGH. F, G, and H over here. So A imefika hapa. Hii ingine iko hapa, A2 iko hapa, A1 ndio iko pale mbali. Then we have FF iko hapa katikati ya huyu. Then pass iko na B, kumaanisha is a mixture. G imetoshana na then hii ingine imetoshana na gani? Imetoshana na hii. Then H imeanzia hapa na itafanya aje? Is the samples F, G, and H. So F, G, and H are athletes at an international sports meeting. They were spotted on a chromatograph. So A1 and A2 are equal drugs. That's why they're P1. So what I told Nana meant that if the spot from the urine will match, a chromatogram was run using a methanol. So meaning they used methanol as the solvent. Like Regan was saying, propanol. Propanol can be used, also methanol can be used, ethanol can be used, any alkanol can be used. Now, identify the athlete who had used an illegal drug. Enda kwa A1. Kwanza, hakuna mtu alikuwa ametumia A1. Nobody had used the drug A1. A2, we have G. G had abused A2. Why? Equal on the same spot. Which drug is more soluble? The one that has moved the farthest distance. So A1 is the most soluble. Are you together? The last question. Tumalizie. Applications of chromatography. Hivyo tukimaliza na hiyo, we call it a day. Yes?
And chromatography is used to see if a food has some illegal substances or if an athlete has abused some illegal drugs.
Okay. Yeah, so let me give it very fast to Malaysia and to test for purity of drugs. Test for purity of drugs during its manufacture. After being manufactured, it is being decided whether they are pure or not. Number two, test whether sports people have used a certain drug. It's called test for doping. Then in cosmetics industry, whether they are pure or not. That is it. Nani kuna swali? Juliet, kuna swali like na Bebel?
No.
Okay. So I have a nice evening. What thank you for following me. Thank you for always being there for me. You can imagine ningekuwa nafunza na hakuna mtu. So that is good. Always from 2 mpaka 4. Every day except on a Sunday. I will always be here teaching. So don't miss it out. Otherwise, I wish you all the best. Receive love a lot from Ambassador Foundation. Don't forget, subscribe.